Thank you, Nathan, for that wonderful introduction. Good morning, everyone. I'm delighted and honored to be here today to share with you all some of the work that we've done at the U.S. Department of Veterans Affairs. I want to start out by thanking Simver for inviting me to present here, especially Dr. David Pedler and his staff, who's helped me extensively in all the logistics of my travel here. I also want to start out by thanking all the veterans and service members in the audience. Thank you for your service. So I don't have any financial disclosures or bias. All the work that I will present today is funded by the US government. And in terms of learning objectives, at the end of the talk, you should be able to understand what it takes to build a large, comprehensive, longitudinal genomics cohort within a healthcare system, the impact of standardizing data collection and curation, how we can provide secure scientific computing, and some pathways for precision healthcare. So just to make sure that we're all on the same page, I'm just going to talk a little bit about the background of the Veterans Affairs and the Veterans Healthcare Administration. We are a separate department from the Department of Defense in the US that takes care of active duty. The mission of the VA is to fulfill President Lincoln's promise to care for those who have served in our nation's military and for their families, caregivers, and survivors. Caregivers was actually added more recently to the mission. There are three branches: Veterans Health Administration, Benefits Administration, and Cemetery Administration, and their names tell you what their roles and functions are in the department. Veterans Health Administration is the largest of them, and it stands atop a triad of three pillars: clinical care, which is the largest, research, and training. The VA healthcare system is a major training ground for nurses, medical residents, and fellows in the United States. So what are some of the assets at the Veterans Healthcare Administration? We are the largest healthcare system in the US and one of the largest in the world, with over 1,300 points of healthcare, which includes 172 major medical centers and over 1,100 community-based outpatient clinics. There are 300 vet centers that primarily provide mental health counseling, and we serve about 9 million veterans who are enrolled in the system every year. Our patient population is stable. Once a veteran comes to the VA for care, they stay with the VA for life. And they are an altruistic patient population, and I don't think I have to tell this audience that. If there is a gene for service, it's in our veterans. The VHA also has integrated within it a national research enterprise, which has been in operation for almost 100 years. And there are world-class clinicians and researchers at 104 medical centers, and each of these have affiliated universities where the VA staff have joint appointments. We're proud to say we have 3 Nobel laureates from the VA and 7 Lasker awardees. Our 3 Nobel laureates are shown there on the right. But perhaps the most valuable asset that the VHA has is its electronic health record system, which is really rich. We have deep data on about 17 million veterans, and this goes back 30 years. And I just show you some of the records that we have in the system. 3.4 billion diagnoses, 11.8 billion lab records, 6.9 billion medication records, 6 billion clinical notes, and 3 million genetic tests. That's an awful lot of data. Now, coming to the research mission itself. So for more than 95 years, VA research has already been improving the lives of veterans and all Americans through the discoveries they make and through the innovation. Our mission is fourfold. The first is to improve veterans' health care and well-being through the entire spectrum of research, from basic, translational, clinical, health services and implementation research, and rehabilitative research. 2, to apply the scientific knowledge that comes out of the research to develop effective precision healthcare solutions for our veterans. 3, to attract, train, and retain the highest caliber investigators. 4, to assure a culture of professionalism, collaboration, and accountability with the highest regard for protecting the privacy and confidentiality of our research participants. This slide just shows you a few of the major discoveries and breakthroughs. These are just a few. You will see the implantable pacemaker, the first liver transplant ever, the high blood pressure medication, the use of aspirin for reducing heart attacks and death, the shingles vaccine, and a large number of prosthetics that have been developed as a result of research at the VA. The VA research has 5 strategic priorities. These are priorities that our current Chief Research and Development Officer, Dr. Rachel Ramoni, has set. Increasing veterans' access to high-quality clinical trials, increasing the real-world impact of research, putting VA data to work, and that includes the Million Veteran Program data that I will talk about today. Promoting diversity, equity, and inclusion not only in research and the research participants, but also in the research community at the VA. And often we have legislative requirements that we have to meet, and some of our priority areas are set by that. In the recent years, we've had these 3. The first is the Hannon Act, which is really to improve mental health care at the VA. There are over 600 requirements in it, and one of them is to establish a precision mental health program within the VA. There's the Cancer Moonshot 2.0, President Biden's Cancer Moonshot Initiative, again, which calls for a precision oncology care for cancer patients, and to reduce cancer death by 50% over the next 25 years. And more recently, the PACT Act, which is to better understand the impact of military exposures in our active duty and veteran populations. And so some of the cross-cutting priority areas we currently have are based on this: suicide prevention, traumatic brain injury, pain and opioid use, precision oncology, precision mental health, and precision medicine in general, and then military exposures. Coming to the journey of the Million Veteran Program. So you all may know that the human genome was completely sequenced in 2003. It took a large number of years and $300 million to have the first human genome sequenced. Following that, there was really an explosion of genomic technologies, which improved the efficiency and brought down the cost considerably. And today, we can get a complete human genome sequenced in less than $1,000 per sample. So it's incredible. So the Undersecretary for Health came to the research office and basically charged us with coming up with a strategic initiative to be able to leverage and take advantage of all these emerging technologies and see if we can apply to improve the way we provide care for our veterans, provide precision health care for our veterans. So we established an advisory committee. That's the first thing we all do in the government. But we had lots of government representatives, but also representation from the outside, from the industry, academia, healthcare organizations. And the first thing that they recommended is that the VHA is an ideal setting to develop a longitudinal genomic cohort, so we can begin to understand how genetics impacts health. And so the first thing we did was really to talk to our veterans and see what they thought about this. This was a time when there was still a lot of fear about genetic research. Giving your DNA to the government, that was not a good thing. And so we went out and did focus groups and surveys of veterans, basically to understand, to get a temperature check, what they know about this, what are their attitudes about this, what are they concerned about, what are their expectations if we build something like this. And to our surprise, there was a lot of support. 83% supported the VA building such a program, and 72% of them said they would be interested in enrolling in it if we built one. Now, this survey was really conducted by a nonprofit agency that was also doing this with the civilian population at the same time. And I just want to mention one thing. When we asked our veterans, what would you expect in return? What do you think the answer was? Nothing. They said, if this can help another veteran, if this can help my brothers and sisters, I'll be in the program. Contrast, the civilian population wanted not only monetary compensation, they wanted vacation packages, cruises, and so on. So you see the difference. Yeah. So major concerns, as we would expect, privacy and security of their information that they're giving to the government. So with this in hand, we brought together some of the best and brightest clinicians, epidemiologists, and scientists within the VA to strategize implementing a genomics cohort within the VA. We sequestered ourselves for 2 days, poring over the focus groups and survey results and kind of figure out, can we do this in the VA, and what should we do? And how big should it be, 100,000, 200,000? And our leader kept pushing us up, kept saying, no, more, and then we finally landed at 1 million. And the reason was that we would have enough representation of all the medical conditions we see in our veterans in sufficient numbers to be able to do meaningful research. So we said, let's go for 1 million. That was bold and that was ambitious, and we had no idea at the time whether we could do it. And sitting at a restaurant at dinner, people were scribbling names on the napkin. What should we call this program? And someone just wrote Million MVP is a nice acronym. And so that's how the Million Veteran Program came about. It took us about a year to get our protocol approved by the IRB, and we launched in 2011, first at 2 sites and then at 9 Vanguard sites, to do a complete end-to-end testing of our recruitment and enrollment procedures. And there was also extensive briefing and communication up and down the chain, sideways, veteran service organizations, the Congress, the leadership, medical center directors, to let them know that this is coming. And so this was just a promise. We were selling a promise at the time. And in the following year, in 2012, we expanded to 25 sites, and then the rest is history, as they say. So the goal of the Million Veteran Program is to prevent and treat disease in veterans by using all of the information, not just the signs and symptoms someone comes to the hospital with, or the labs, but using their military experiences, environmental exposures, lifestyle, family history, genetic information. Use all of the information about an individual to inform and guide choices that patients and providers make in their clinical care. So we set 3 specific aims. The first is to establish a comprehensive and diverse longitudinal genomic cohort, 1 million strong. We said 1 million strong in the beginning. Now we say at least 1 million, because we're almost there. And then to establish a secure scientific discovery platform for generating scientific discoveries, and then lastly, to establish pathways to clinical translation, because that's the whole purpose. So what does enrollment look like? Now, currently, any veteran in the US is eligible to participate, but when we started, it was really at the large medical centers with veterans who were getting at least part of their care within the VA healthcare system. And the reason is we would then have access to their rich medical history. So they would come in, or more recently, we have an online platform as well, but initially they would come in, complete the informed consent and HIPAA authorization, provide a blood sample at the VA facility, complete surveys. There were 2 surveys. One is a baseline survey that just gets health history, and a more detailed lifestyle survey that really goes into the lifestyle, exercise, food habits, more detailed mental health questionnaires, and so on. And they grant access to their health records, and they agree to be recontacted in the future. We built an entire informatics team to set up the centralized recruitment and enrollment process. So we just send out invitations. We invite veterans who are getting health care to join the program. And when they respond, it also triggers an automatic appointment scheduling for them. We also established a call center where veterans can call, get more information about the program. They can also make appointments at their VA at the hospital while they're on the call. So I don't know if you can see this clearly, but today you can join MVP in person at one of our currently active 67 sites across the country, or you can join online. We have a web portal. And you can see here that the US Postal Service has really helped us in getting to this phase. We have sent out over 25 million pieces of mailings to veterans, inviting them to join the program. And we've reached out to about 8.5 million individual veterans in the system. Online, they can complete their informed consent and HIPAA authorization. They can complete surveys online. They can also self-schedule their appointments or request for a home collection blood kit to be sent home. This is just the landing page of our web portal, and I would encourage you to go and take a look at it. It's easy to remember, mvp.va.gov, and if you go to the Science Corner, you will see all of the research that's going on and a list of all the publications that have come out with links to the publication right there. And as you can see, we've passed the 985,116 veterans already enrolled, and now we're counting down the last 15,000, less than 15,000. We have an aspirational goal of getting to it by Veterans Day, which is November 11th. But even if we don't make it then, it will be imminent. We had a small biorepository at the time when we started, which we expanded. And now what we have is a full-service biorepository with a robotic nitro store, which can hold 4 million aliquots. This is at the Boston VA. And again, this is full service. They provide the collection kits to all our sites. They train the coordinators. They process the specimens. Specimens that are collected are shipped back to our central depository every day in the evening. And samples arrive in the morning, and they start processing them right away. And they do about 2,000 to 2,500 samples a week in the peak. We isolate some small amount of DNA right away, so we can send it out to our contracted vendors for generating the genetic data. And then mostly we store two aliquots of Buffy coats from which you can isolate DNA later. We also store 4 plasma aliquots. So plasma, where you can do things like metabolomics and proteomics from that. So that's stored in our second biorepository at the Albuquerque VA. This is what our enrollments look like across the fiscal years. As you can see, we almost reached a sort of steady state of 100,000 veterans every year until 2020. And of course, we all know what happened then. We had to completely shut down all of our operations. Fortunately for us, we had just launched our online portal in 2019. And so that sort of helped move along, but still, our patient population is still not, hasn't warmed up that much to this electronic enrollment process. They prefer the paper copies of the surveys. They prefer to come in and meet a staff person and enroll in person. But, so that's what it looks like. The question I do get asked is, what will happen after 1 million? And so we're not going to stop after 1 million. The program will be open for any veteran that wants to enroll. And we will focus on diversifying the cohort more as we go forward. So this slide shows the cohort demographics. It's 90% male and 10% female, and this aligns with the VA and the VHA demographics. We've launched a couple of campaigns to increase the number of women veterans that have been very successful. So that's one thing that we will continue. We have almost 100,000 women in the cohort, which is still large enough to do studies, but we would like to increase that component. We have 8% Hispanic, which also aligns with the VA demographic. We have one of the world's largest cohort of people of African ancestry, over 170,000 enrolled in the cohort. And this you will see when you look at the science. We are able to discover genetic variants that are specific to some of these underrepresented races and ethnicities. The average age is 67. They are older veterans. again, we are starting some campaigns to enroll more younger veterans in the cohort. On the right side, you just see the same thing in a pie chart, but you will see on the top there some of the others like the Native Americans or the Pacific Islanders or Asians are very small numbers, 1% or less. So going beyond the million, we will be doing focused campaigns to increase all these underrepresented populations in the cohort. So this is what the data universe looks like. Don't worry about those acronyms on the right, but if you look at the bottom left is all the clinical data that we collect passively from the electronic health records. Participants don't have to do anything about this. On the right, you see some non-VA data. We do have permission from our participants to get data from the National Death Index, the Centers for Medicare and Medicaid Services, because our veterans do get part of their care outside the VA, and we are able to bring in those records in through this process. We also get some data from DoD. Of course, for the security and privacy purposes, we can't get everything, but we do get certain subsets of data from the Department of Defense. On the top, the two circles are data that we actively collect from our participants. On the left are the self-reported surveys, and I'll tell you a little bit more about them in a minute. On the right, all the data we collect from the blood sample that we collect from our patients. So I told you that all of the biospecimens are processed right away. We isolate DNA. We do baseline genotyping on every participant in the program. So that is about, the array we have has about 765,000 genetic markers on it. And then by imputation, you can increase that to about 45 million. You impute it to whole genome sequences from the 1,000 Genomes Project, the NIH, or the African Genome Resource. And more recently, we've imputed this using the TopMed data from the National Heart, Lung, and Blood Institute. So that gives us 45 million genetic markers for every person, and that's done on all the samples. And then we do some secondary data generation from that, the HLA typing, the mosaic chromosomal alterations, mitochondrial genome, all this can be done from that data set. And early on, what our scientists told us is that the array we're using is not really good enough to identify markers in some of these underrepresented non-European ancestries. So we've now have a customized array that is really enhanced for those markers. And anyone who is from a non-European ancestry gets their genotyping done on this platform as well. So we are increasing our chances of identifying genetic markers in these populations. So it's all about cost. All of these technologies are expensive, and so doing everything on 1 million people might not be possible, at least not right now. So we've decided to have a 100,000 random cohort where we would go do deep data generation. So in addition to the genotyping I just talked about, we're doing whole genome sequencing. We've done that on over 140,000 samples right now. We are generating metabolomic data from the plasma samples. And also we just finished our pilots on proteomics on 2 different platforms. And we will be selecting one to move forward to get to 100,000. So all I talked about now was about the molecular data from the blood sample. Now just as much, equally important, or even more important, is the clinical data. The electronic health record, even though it's one VA and we have one record, every hospital has its own instance of the EHR. So there are differences, variability in the way people code, and coding is really for billing purposes or for referrals to specialty care. And so you have to clean and curate the electronic health record data. How do you know if someone actually has PTSD? Is it just an ICD code? Sometimes an ICD code is enough, like for blood pressure or something like that. But if you're doing a complex disease, just the ICD code isn't enough. You have to add, how many visits did they have for that purpose? Were they on meds that are relevant to that? And so on and so forth. And so there's we've established now a core of experts who clean and curate the electronic health record data. And they put this into a library, which we call the Centralized Interactive Phenomics Resource, or CIPHER for short. So basically, there's no data. It's just definitions of phenotype. How do you find people with X disease in the EHR? So there's a definition. There's all the metadata associated with it, the sensitivity and the specificity of the algorithms they use, all of that, any publications related to it, everything is in this library called CIPHER. This team also develops automated tools. You know, initially we did everything manually. It just takes a lot of human hours. So now we're automating a lot of this phenotype validation. And we're partnering with our colleagues at the Department of Energy that have helped us come up with natural language processing tools. You know, I told you I showed that there are 3 billion clinical notes, physicians' notes. To be able to get information out of that, there are natural language processing tools that have now been developed at the Department of Energy for the VA EHR. We're also using artificial intelligence and machine learning methods to derive as much information as we can from these non-structured parts of the EHR. Similarly, we also need to clean and curate the self-reported survey information we get. Survey completion is voluntary. And so the baseline survey, we have over 580,000 who've completed them. The lifestyle survey, which is the longer one, we have more than 450K. And in that, we used a food frequency questionnaire. And so we have curated the largest nutrient database on 400,000 people in the cohort. And that can enable a lot of nutrigenomics that's popular these days. When the pandemic hit, we developed a COVID survey and sent it out to everybody. We got 250,000 of those back. That's available for research on their individual experiences with the pandemic. The Gulf War Illness Survey, and more recently we launched a very, it's pretty long, it's 100 pages long, it's a mental health survey. We're piloting it now to see how well that does. So we can really increase the amount of information on the clinical side as we increase all of the molecular data from the blood specimen. And this just shows the CIPHER. I mentioned the phenomics resource. So right now we have over 5,600 phenotypes that have been cataloged and over 5,800 users of this resource in the VA. And happy to say this June we actually opened up this to the public. We have an open access portal where other healthcare organizations can go in and take a look at how we define various conditions. And the link to that is down there in the slides, and you all will have access to it. I would encourage you again to go and take a look at that as well. And it's now mandatory. Every researcher who curates a phenotype has to submit it to this library so it can be repurposed and people don't have to reinvent the wheel. So we have the data. Now we have to provide that data for research. So we established a Center for Data and Computational Scientists. It takes a lot of work hiring all the right experts to come in and build this for you. One of the decisions we made was that we would never send out data because you risk, security that way. We decided that we would build a secure, centralized scientific computing environment and provide all the analytic tools, and we bring researchers to the data instead of sending data out. And so that's exactly what this center is doing. This basically shows our principle. So on the left, you have the warehouse, all the cleaned and curated data, whether it comes from the surveys or the EHR or the biospecimens are all there, stored in there. And they're all stored with your individual code. There is no direct identifier like names, social security numbers, address, date of birth. All that is not on any of those. But we have an honest broker system within our, which is called the VA Genesis, within this environment that can actually link all the codes to the individual and provide anonymized or coded data to researchers who are approved. Researchers access the data once they're approved using their VA network credentials, and then they're given a study mart with all the data they need for their study and all the analytical tools that are required for them. And once they complete their analysis, they can take out only the summary data, summary level data and summary statistics. No individual level data leaves the system. More recently, we got access to the VA Enterprise Cloud. We have both Amazon and Azure platforms there. And we are able to now, if people want to do a high compute intensive analysis, like with whole genome sequencing, that they cannot do on the on-premises servers, we just port the data up to the cloud, they finish the analysis and bring it back down. That's it. So now we're testing this whole ability to move data into the cloud on demand. So our goal was not just to keep the data within the VA, and right now we're an intramural research program. It's only available to VA researchers. We really want to make this valuable data set available for research everywhere. And so at the bottom here is the Vinci Genesis, what I just mentioned to you. That's within the VA environment. Top right, you see our partnership with the Department of Energy. So we have an entire copy of the VA electronic health record moved over through high-speed internet to the Oak Ridge National Labs, and it's updated daily, or nightly rather, as it is within the VA. So they have a current copy of the EHR over there. There's also a copy of the Million Veteran Program data over there. And we have some very high advanced computing environments available to us, supercomputers that are available to us, and I'll tell you about a research project in just a minute. On the left, we have the VA Data Commons. This is a contract with the University of Chicago. Here, we've moved a subset of de-identified MVP data, again, curated, research-ready, with all the tools, and we are beta testing this now. This is where the outside world, outside of the VA, will be able to access this data set in the future in a de-identified form. So while we wait for this to be in place, there are other ways people can still get access to some summary level data. Every MVP study deposits its summary statistics into the NIH dbGaP portal. And so already it's being used. As you can see, we've had nearly 250 requests for this data in that environment. People are analyzing over there, and there are publications coming out by analyzing, doing downstream analysis on this summary data. Again, the links are in here. I'd encourage you to take a look at that as well. Science, that's a key performance metric for us. Why did we invest all this money and build this resource? Really, the first line is to make scientific discoveries possible. So we have currently within the VA over 100 projects, and we have over 350 publications. And again, I encourage you to go and take a look at them in our web portal. They are in some of the very high impact journals, and there are links to those publications right there. The topic areas actually cover the entire spectrum. You know, any condition you see in veterans. Here are just some key ones that have already been studied. And I'm not going to read all this out, but you will see that there is a whole spectrum over there. And just as a matter of the publications, what we've been able to do is do some of the largest genome-phenome association studies. For example, you'll see there, genetics of blood lipids among 300,000 multi-ethnic participants. No one's done that before. And out of that came some potential new treatments for heart disease and diabetes. More recently, we published a genome-wide association study across ancestries for suicidal ideation and found some new genetic markers associated with that. Tinnitus, traumatic brain injury, are very relevant to veterans. And another recent article in this was on the polygenic risk score. Sometimes it's not just one gene. Most times it's just not one gene or genetic marker that's associated with the disease. So this paper was about a polygenic risk score that was identified in men of African ancestry through the Million Veteran Program data. And this is actually now being tested in a clinical trial to see if you can, combining it with standard of care screening for prostate cancer, to see if it improves prediction, the ability to predict and preemptively treat. So I mentioned the collaboration with DOE. Now, researchers will typically take one disease, say diabetes, and look at all the genetic markers that associate with it. So that's a typical genome-wide association study. Or you flip it around, you take one genetic marker and look at all the phenotypes, clinical conditions that are associated with it. That's called a phenome-wide association study. What we've been able to do with the Department of Energy supercomputers is take 42 million genetic markers and about 2,000 health characteristics, analyze all of that to see what associates with what in one go. Well, one go meaning it took a long time, but you know what I mean, like we're not doing one disease at a time or one genetic marker at a time. So these results are also going to be, the summary results will be in the dbGaP at NIH, will be accessible to the public. The paper is now in Revise and Resubmitted Science. So we're going to coordinate the availability of that data with the paper being published pretty soon. That's coming. So we talked about the science. Now, ultimately, we're doing all this to really move scientific discoveries into clinical care. So we had a task force that looked at all the potential ways MVP could be leveraged towards clinical translation and into the clinic. And one of them was returning genetic results. And so there's lots of data, information in here, but what I want you to really pay attention to is that we do research-grade clinical sequencing, genetic markers. So in order to be able to use it in clinical decision-making, we have to re-sequence and confirm it, validate it, make sure that that's the correct sequence before you use it. So we are doing 2 pilots right now. One is in metastatic prostate cancer. We're having certain genetic markers in DNA repair genes, like BRCA1 and 2 and all those others mentioned there, can actually make you more responsive to certain kinds of treatment, like PARP inhibitors in this case. And so we've actually reached out, recontacted almost 2,000 participants, living participants in MVP with metastatic prostate cancer, repeated this test. And the bottom line is we have 53 who have tested positive for at least one pathogenic variant. And we're now following them up. They all get genetic counseling post-test, and then they're being followed up for treatment options and better care. I have lots of, vignettes that I've heard from veterans who participated in the study and how it's benefited them. It's mind-boggling when you actually see your research being translated into care. We're also doing some cascade testing, and that is testing for first-degree relatives, because some of these are inherited, and so if you find one proband, with the marker, you really need to test family members also for it. So, and similarly, this is so about treatment, so giving the right treatment based on your genetic markers. The other pilot is on familial hypercholesteremia, that's inherited form of high cholesterol, where you have the gene for FH, the genetic marker. So there you can actually, if you know you have the gene, you can start treatments earlier, you can modify your lifestyle and diet. So again, you improve health at an early stage. So again, there you have 78 participants in that study who have gotten a positive test and are being followed up. Again, we're going to be doing some cascade testing with first-degree family relatives in that as well. And then there were 2 other areas where within the VHA, the clinical side of the house, the clinical programs are also beginning to take advantage of genomic medicine. First is in pharmacogenomics. So this just shows in the last 2 years, the VA sites that have increased now and are doing pharmacogenomic testing. But there are so many panels. There are multiple companies that sell pharmacogenomic panels. Everybody does their own favorite panel. So it's not standardized. In other words, sometimes you can't compare results from one with the other. So we are now embarking upon a national pharmacogenomics program within the VA. So we're looking at developing a single VA pharmacogenomic array test that will be used across the VA system. And we're going to hire more pharmacists and train them to really be sort of gatekeepers for these pharmacogenomics, provide clinical decision support tools for them, for all providers as well at the time of making or prescribing, to alert them towards drug-gene interactions, where they might be adverse or what might be recommended, et cetera. So this is in the making, and we are partnering with, you can imagine how the MVP platform, already having 1 million people, having baseline genetic information, can contribute to this effort, and we can validate each other's findings. So that's one second piece that we have started on the translational track. The third is precision oncology. As you may know, the cancer or oncology is one area where precision medicine is already in practice. It's pretty advanced in that case. And here on the left, you will see even within the VA, where sequencing or doing a genetic test back in 2015 was 130 a year. Now it's over 12,000 a year. So there's an increase in the amount of genetic testing done for cancer within the VA and for different types of cancers as well. So we are now establishing, and the goal especially of this program is to, again, look at all the data, the electronic health records, radiology reports, the medications, pathology, and visualize it and get information out of it and use that in the clinical decision making. So we're already doing that in MVP. This framework has already been set up. So we are now mirroring the infrastructure we have for MVP for precision oncology within the VA. They're going to be side by side within the same computing environment. So we can now go back and forth between learn from what's happening on the clinical side, inform the research, and vice versa. So this is where we want to be. This is the ideal state. We want to get to this where the clinicians are informing, or clinical practice is informing what research we need to focus on. And research is going back into the clinical care to improve care. So all this while, I've told you how wonderful everything is, but this did not happen by waving a magic wand. There were lots of challenges we had to overcome. And this program was really groundbreaking and paradigm shifting in many ways. And I'll just mention a couple of them. The first was really broad consent for future research. Most researchers are studying a disease, they recruit patients, they enroll them in their studies, get whatever biospecimens they want or whatever data they want, they use it however they want, and you would leave them alone. That's how they prefer it. We were saying, well, we want you to give us a blood specimen, we're telling veterans, and you're going to consent for any future research in any area. And this was, really groundbreaking at the time. And we spent almost a year bringing in ethicists and various experts to talk to our central IRB and eventually at the end of the year, they were convinced that this is something we can do. We're not harming any individuals by doing this. And the other thing was, again, the philosophy, as I mentioned, people like to be in control of, whom they recruit, how they recruit, what they do with the data. We were turning that upside down and saying, we will centrally recruit all the patients, 1 million of them. We will collect their blood specimens. We will generate the data. We will curate the data, make it research ready. And by the way, we're not going to give you the data. You are going to come to the data, do your work, and take your results. So that was paradigm shifting, and there was a lot of apprehension in the beginning. No one, really liked this idea. But today, as you can tell, and people are thriving, they love working with this data set. And it's the future, for sure. The other point is funding, right? So many of you may have heard of the All of Us research program at NIH. So this is a similar program in the civilian population in the US. They were given a $1.5 billion to build the program. Zero. We had to build this whole program with the research funding we had in VHA, which is a small drop in the bucket of VHA funding. So that was another challenge. And IT is a separate appropriation in the VA. So we have the clinical care appropriation, we have the research appropriation that we get directly, and there's a separate IT that comes to VHA. So research does not have a central, a line item for IT. So that was another struggle we had to overcome, and our current leader had to go to the Congress and actually use a cake baking analogy and say, well, you want us to bake a cake and you're giving us the eggs, the sugar, and the water, and no flour. IT is the flour we need, and we can't bake the cake without it. So finally, in the recent years, we've managed to get IT funding, and that's how we've been building this entire computational infrastructure. So where do we go from here? It's, we are getting to our millionth enrollee pretty soon. And beyond that, we'll be increasing diversity, broadly expand data access, increase the kind of projects we can do in this, especially now we have a task force that's looking at how we can inform the military exposure, look at gene-environment interactions, and so on with this data set. That's underway. And finally, the next 5 to 10 years is going to be all about moving discoveries into the translation pipeline. So I'm going to stop there, and really this is blood, sweat, and tears too, really. A lot of people, there are 300 people across the country working on this program who passionately believe in this mission of the VA and of this program and the promise. And many of them have been there from day one when we sat around the table thinking, asking ourselves, should we do this? So I'm indebted to all of them, and most of all to our veterans, the nearly 1 million veterans who have come forward and rolled up their sleeves and said, we will do this for nothing if it helps another veteran. So on that note, thank you for giving me this opportunity.